We have that exams in Professor A's elementary stats class are normally distributed with a mean of 78 and a standard deviation of 5. So the info that we have from the problem is that mu is equal to 78 and sigma is equal to 5. Now, Sally scores an 86 on the exam. So what we want to know is what's the probability that a student in the class did worse on the exam than Sally? So to do worse than Sally, the student would need to have a score that's lower than Sally. And when we're talking about a mean of 78 and a standard deviation of 5, this is not a standard normal. We're going to need to turn it into a standard normal, which we call a z. So we start with looking at the probability of being less than Sally's score of 86, and we're going to call this an x because it's in terms of a normal distribution centered at 78 with a spread of sigma equal to 5. In order to look it up in our table, though, we need to transform it or standardize it into a z. So to do that, we know the formula says that z is equal to x minus mu divided by sigma. So what we will do is take our values in our inequality, our x, we're going to subtract our mu, which is 78, and we're going to divide by our sigma, which is 5. We need to do that to every number within our equation, so we will take our 86 and subtract the mean of 78 and divide by our value of 5. And this will keep it so we have not changed the probability at all. So x minus 78 over 5 is just x minus mu over sigma, which is a z. And then this other value will give us a number. And if you compute the number, 86 minus 78 over 5, you will get a 1.6. So we want the probability that we would get a z, which is now a standard normal, less than 1.6. And this we can go and look in our table for. Our table is set up to give us less than, and that is what we want in this case. So we will look up 1.6 in the margin of our table. We can treat 1.6 as 1.60. So we will be looking at this column here with the 0, 0, and we'll be looking for where we have a 1.6. So 1.60 is right here. We get a probability of 0.9452. So the probability, if the scores were normal with a mean of 78 and a standard deviation of 5, of scoring less than an 86 or doing worse than Sally is 94.52% or 0.9452.